get underway. Yeah, those who are chairless, we brought in more chairs. So if you do not have a seat, look towards the back. Can you guys hear me okay? Yes? Project? Good. Okay. So if you don't have a seat, there are seats down the back. Wow! We ran out of seats, which is a good thing. Wait a second. Oh, there's more up front there. If anyone is not shy and wants to be up front, we also have seats up there as well. Alrighty. Well, first off, welcome. Welcome, welcome. Thanks for joining us. Yeah, I was about to say running out of seats is a good thing. I remember doing this last year. We were probably about half the size. So I think this speaks to where MongoDB is going in the Dallas community, your enthusiasm. So thank you for coming out. If you don't have Wi-Fi and password are up here. So I'm going to do a little bit of housekeeping before we get the agenda underway. First, we'll start with some introductions. My name is William. I'm an account executive with MongoDB based here in the Dallas area. Does anyone want to take a guess at what the accent this is?
Ireland.
There we go. The guy with the red hair, he got it. I get lots. I get told Australia. I get told England. Yeah, I've lived here for about 7 or 8 years. And I cover the TOLA region for MongoDB. So Texas, Oklahoma, Louisiana, and Arkansas. In the enterprise space. So companies that are deploying into their enterprise stack, or they're assessing or evaluating MongoDB. And there's actually a whole team of us here this evening, and that's what we do. We work with companies who are doing that. I'm going to do some intros to the Mongo team because they are kind of scattered throughout the room. So if you are a Mongo person working for Mongo, put up your hand. Bunch of you. Okay. We're going to have some speakers. The guys with their hands up, if you have questions afterwards, go find them. They represent some of the sales team, some of the engineering team with Craig. We have some of our consulting team here, so go find us afterwards. You'll see a little Mongo on our badge and come up and talk to us. Hold on. Thank you to IBM. If you haven't visited the IBM booth, thank you for sponsoring this event. You guys are giving away something, right?
Yes, virtual reality headset.
Virtual reality headset. Who doesn't want one of those? So there's going to be a raffle?
Yes.
Okay, so if you haven't gone and visited the booth, go get yourself a VR headset. Why live in the real world? Live in the virtual world. Hold on. The other thing, tweet. Please tweet. Who's on Twitter? Who uses Twitter? Who's going to admit to using Twitter? Okay. Handful of you. If it's good enough for the president, it's good enough for you. All right? Tweet tonight, MongoDB evenings. Use the hashtag. We're going to be giving away prizes. There's going to be t-shirts. There's going to be random swag. So if you are on Twitter, use that hashtag. We'll be picking a random one at the end of the night. So what are we going to do and what are we going to talk about? So hopefully you guys have all found the food and beverage. That was pretty obvious, so good start. I'm going to do a quick intro to MongoDB, and I'm going to do a quick poll before I do that just to gauge where people are at in terms of their MongoDB usage. And then we're going to have 3 talks. We're going to have Gopal Raghavan, who's going to do a talk on data modeling, and he's one of our solution architects. We're going to have Pat Sheehan, who's going to do a talk on BI connector, business intelligence and data analytics using MongoDB. There's Pat, put your hand up. And then we are lucky to have a customer speaker as well. So Travis Tidwell, CTO with Form.io, is going to talk to us as well. I don't have his presentation up because we're going to do kind of a people's choice thing. So you've got a couple of options of what you can talk about. So he's going to do a quick poll before he does his. So surprise. And then we're going to do some Q&A. We're going to be around afterwards, and we're going to do some announcements as well. So let's do a quick intro. But before I do that, pretend there's 3 graphics there. So who's actively using MongoDB? Builds on top of it, has apps in deployment. Okay, show of hands. Who is thinking about MongoDB? Sort of early stages, wants to evaluate. Okay. Anyone managing a MongoDB environment, sort of DBA focused? All right, okay. Anyone, none of those? Okay, never touch NoSQL. Okay, there we go. That was a couple. So why are organizations adopting new database technologies? They spend all this time and money and effort in SQL Server, in Oracle, a lot of skills, a lot of development knowledge in those spaces. So why are organizations looking at new databases. It's really down to three things. We have maybe 15 to 20 conversations a week with folks in various sizes of enterprises. It kind of boils down, if I was to summarize it, it boils down to this. I want to develop data-driven applications that takes advantage of all the data in my business. I want to do it quickly, because nobody wants to move slower. I want to have flexible deployments and flexible models that I can use, and I want to figure out how the cloud integrates into my stack. So if I was to sort of summarize the types of conversations, all the projects are different, but they tend to be around those themes. And those themes present a bit of a design challenge when you talk about relational databases. I'm not saying that there is not a spot for relational technology, do not get me wrong, but there's a little bit of a design challenge when it comes to doing those things on relational technology. And it boils down to these three areas. Data is so different today than it was when relational databases came to. Right? I don't think, is there anyone here who would disagree with that? Data is just different. Right? There's unstructured data, which is probably growing at twice or 3 times the rate of structured data. There's various types of sources, the speed of it, integrations between relational systems. You know, that type of complexity exists in the enterprise stack today. Development methodology. So agile, moving to a quicker deployment, microservices, those types of things. And deployment models. How do you use the cloud? How do we use a public cloud? How do we use a private cloud? Was that hand up? So these types of themes really present a design challenge or a complexity when you're thinking about using relational database technology. That is really why organizations are looking at NoSQL, and then specifically looking at MongoDB. So why are organizations adopting MongoDB? You can tell I'm not a big fan of a lot of words on slides. 3 things. Significantly reduces development complexity and ops complexity, which translates to a cost and time savings. If MongoDB was not doing that in the enterprise space, people wouldn't use it. It would just be a nice to have. So that's number 1. Number 2, enterprise-ready operational database. That's very deliberate language. When I say enterprise-ready, if you were to look in the NoSQL space, anyone take a guess how many NoSQL databases are out there? Hundreds? Probably between 200 or 300 that call themselves a NoSQL or a non-relational database. There's really only a handful that are actually enterprise-ready or can be deployed into an enterprise stack. Okay? And that's to do with operational maturity, tooling, integrations, security, the things you actually need to go deploy into the stack. If you look at that small subset of NoSQL databases, MongoDB is top of that stack. It's the most popular NoSQL database in enterprise. And number 3, deployment flexibility. So whether you're deploying on-prem, or you're deploying in your private cloud, in the public cloud, or you're using a managed service. Anyone here using Atlas, MongoDB Atlas, our managed service? Besides Craig, who works for us? Okay, a handful. If you were, it's new. Yeah. Atlas is new. Yeah. It's a new product. If you hadn't heard about it, we can answer questions about it later. But
you got a great user interface, though.
There you go.
Thank you. Free tier now.
There is a N0, which is a free tier, so the barrier to actually using or trying out Atlas is pretty low. And by that, I mean free. So you can actually go and use Atlas with for no cost. So go check it out. So those are the 3 reasons. That's why people are adopting MongoDB. The other reason they're adopting MongoDB is, if you were to look at, when I call MongoDB an enterprise-ready database, it's really because we combine the best of relational and NoSQL. So what do I mean by that? If you look on the left-hand side here, if you look at the core strengths of relational technology, expressive query language and indexing, strong data consistency, enterprise management integration, you're probably nodding your head going, yeah, they've had that in the relational world for years. So this is pretty new in the NoSQL world. Not every NoSQL solution has these things in it. MongoDB does. And if you look at when I say NoSQL flexibility, what does that mean? Flexible data models. So the JSON data model is very powerful. It allows you to do a lot, ingest data from lots of different sources, at velocity, at different sizes and shapes, commingle that data. It's a very powerful data model. Scalability and performance. We have some of the biggest companies in the world who have standardized on MongoDB as a database technology. So when they're building new apps, they build on Mongo first before they consider any other database technology. And then always on global deployments. And that's kind of back to the point I made just a minute ago. big companies are deploying on top of MongoDB. When I say we're a global company, this is what we mean. We have a global footprint. We have about 2,000 customers. We have about 15 global offices, including an office here in Dallas. And then we have about 30 million downloads of the software a day, or in total, sorry. That's multiple tens of thousands a day. That's a lot. Except for Greenland. I don't know why. Yeah. Greenland is just not a NoSQL fan. In terms of customers, every vertical you can imagine, very big in finance and insurance, telco, utility and energy, media and entertainment, retail and e-commerce. I'm not going to go, for the sake of time, I'm not going to go through all of these. Just know that there is a footprint across all of these industries. MongoDB is really built as an operational database, which means when you look at the use cases that we can satisfy in the enterprise world, it's probably about 90 to 95% of what you'd want to do in that space. So it's really built as a workhorse database, and the fact that we're in so many different verticals and so many different industries sort of speaks to that. And then use cases. Again, I won't go through all of these for the sake of time. There's a bunch of different use cases that we can fit into. We're built as an operational database. So single view, IoT, mobile, analytics, catalog, personalization, content management. People call these different things, but the net of it is there's a lot that we can do as an operational database. That's it. That was my intro to MongoDB. I wanted to give you a sense of where we're at as a company, our global footprint, the types of things that we do, and the types of customers that we serve. So I'm going to pause here, and then I'm going to hand over to Gopal, who's going to talk about data modeling in MongoDB. All right.
Thank you, William.
Okay, if you need to use that.
Actually, I'll probably move. Pat, do you have it loaded or?
It's open. It's in the background.
Yours is number 2.
All right, guys, thanks for waiting. So my name is Gopal Raghavan. I'm a solutions architect with MongoDB. I'm based locally in Dallas, right? So what I do is I work with Fortune 500 companies across the TOLA region. For today's session, we'll talk about data modeling in MongoDB, how that compares and contrasts with in traditional RDBMS. And then we'll go into some examples on how we have used those principles to model using an e-commerce website.
Gopal, hold the mic up to your mouth.
Okay, can you hear me now?
Yeah.
Thank you.
Keep it there, keep it there.
Thank you. Can't move that hand. Okay, so we'll walk through a shopping site. We'll look at some of the entities and relationships between those in the shopping site. We will compare and contrast traditional relational database data modeling with MongoDB, and then we'll apply some of the principles to the shopping site example, and then we'll also look at the performance considerations, and we'll go into a Q&A. I'm also available outside after the show, so if you guys want to meet up with me, I'm able to do that as well. So this is a very popular shopping site. So you see, everything is personalization driven by the customer. So you see 3 entities right off the bat. You have a customer, you have the orders that the customer places, and the products the customers either browsed or shown an interest in, right? So if you take the anatomy of the orders, so the customer is the primary entity. So in other words, in relational terms, that would be considered a strong entity, right? And the orders here are considered weak entities because orders by themselves don't really make any sense, right? So you can do analysis by orders, but really you want to use the customer as a context before you start to analyze orders. And orders has attributes like when was the order placed, what is the order amount, whether the order was rejected, whether it was shipped, and so on and so forth. So the next entity that you saw here was product. So product, in this case, is a book, right? So a book has multiple attributes. You have reviews. You have other things like whether it's available in a hardcover or a softcover, and then authors. So what we'll do is we'll focus predominantly on the authors relationship here. So the relationship between a customer and order is one-to-one or one-to-many, because a customer can have one order or they can have multiple orders, right? And the relationship between a product, which is in the case book, and then the author is many-to-many, because a book can be authored by multiple people, as well as an author can also co-author multiple books. So it's a many-to-many relationship, right? So if I were to look at the modeling paradigm in a traditional database, this is something that you guys are probably very familiar with. Normalization. So it's been around for a while. Normalization was something that was basically conceived because storage costs in those days were pretty expensive. So they wanted to figure out a way to kind of minimize the repeating groups so they can optimize and then save for storage. But then when you have to essentially pick up some piece of information, you have to do that in runtime, where you'd have to run multiple different joins to get the information that you want or answer to a query that you want. Now that's okay for small amounts of data where there's really no impact in terms of performance. But when you want to process large volumes of data, that's when the performance degradations start to show up. And then typically when you start to work with object-oriented languages like Java, for example, you'd have to use some kind of an ORM layer like Hibernate to kind of translate and then solve the impedance mismatch between the relational entities and then your object-oriented programming language, right? So it's also very hard to maintain because as and when your entity relationships are, get pretty complicated and wide, you'd have to have so many tables, so many joins, and it gets pretty cumbersome to maintain and also to process. Now, if you look at the modern application needs are going to be pretty rigorous, right? So applications are no longer going to be departmental based. It's going to be more open to maybe the world. Very critical because they drive revenue. They have to be up 24/7, and they have to process variety of data. So which means we're talking about multiple shapes, high volume, high velocity, right? So the old way of doing things is not going to really contribute to agility because people have short sprint cycles. Business requirements change so often that it is not possible for you to go through a methodology like waterfall to build applications, right? So the rigid schemas are not going to be of any value here. So let's take a look at this graphic. So in my ask is I want to get a picture of this particular car, right? So if I was to do something in a normalized schema, I'd have to model every part of the car, right? So I'd see the part, the tires, the engine, the struts, etc. All of them have to be modeled and normalized, right? But in my case, if I just want the car, I'd have to go do joins to all those different components to fetch me a picture of the car, which is not really efficient, especially if I'm dealing with lots of volume. Now again, if I were to show you an example of a normalized schema, if a person just wants term information, I'd have to do 4 reads, but then I have to store all the other information which may or may not be used, right? Or it may be not accessed as frequently as people would like to think. So that's why we start to look at a new way of modeling, which is document modeling. So for folks that are new to MongoDB, like myself, for example, so I came from a relational world as well. So there is some terminology that we have to kind of understand, right? This is basic foundation. So a database in a relational database is equal to a database in MongoDB as well, right? A table in an RDBMS is equal to a collection in MongoDB. So whenever you say collection, it represents a table. Now a row in a table, a traditional table, is equal to a document in MongoDB, right? So document is going to be your unit of a description, entity description. A column in a traditional RDBMS is equal to a field in MongoDB. The only difference is a row in a table would have to have predefined columns, whether you store values or not. Whereas in MongoDB, you don't have that constraint. You can have variable fields. So for example, if I'm storing 2 or 3 types of products, one product could have 4 fields in a document, the other product could have 10 fields. There's really no need for you to carry extra fields when you don't need it, right? So that's the important thing to note here. And then, like a traditional database, we also have indexes. We have 64 indexes, B-tree indexes, and you can create any index like a single value index, a compound index. You can create indexes to cover queries. We also have specialized type of indexes for text searching, time to live index, which is something that pretty unique to MongoDB, and so on and so forth. So there's quite a bit of things that we offer that kind of resonates with the use of RDBMS. And we also support joins in a couple of different ways. So you have a concept called embedding, and I'll go through that in the sections, the following section. So this is where you kind of combine the information that you access together into a document. Linking is where I take some IDs of a different document that is related to another document. I can store it in arrays. Right? That's linking. And we also have runtime joins. So we have something called a lookup, which is a left-out join. It takes it takes data from the right collection and then moves it into the left collection as an array of subdocuments. And then also graph lookup. And graph lookup is another feature of our aggregation framework, which gives you the ability to solve for use cases like fraud detection or social network, sphere of influence, and all that. So if I look at the schema design paradigm changes or paradigm differences, in a traditional RDBMS, I'd say, what answers do I have, right? Essentially, that's where I'd start off with. In MongoDB, it's more like, what questions do I have? So I start off with, what questions do I have? And then in RDBMS, I'd say, what data can I store? So which means, as you saw in the earlier graphic, I had this car, I had it broken up into all different parts. That's the data I'd store. Whereas in MongoDB, I'd say, what data can I use? Which means that it's all access driven at this point, right? And then in a traditional RDBMS, it's a 2-dimensional attribute. So which means you have the rows and you have the columns, right? In MongoDB, it is multi-dimensional, which means that I can store any number of levels, and all the levels can be jagged. It could be essentially, n-dimensional attributes. I can query on any field in an RDBMS. In MongoDB, I can query on any field in the document. In addition to that, I can also, query any level. Right? That's the important thing to note here. And in RDBMS, it's going to be very highly structured and rigid. In MongoDB, it's highly flexible because a document does not need to have fixed amount of fields if you don't want it. So here's an example of how you would model. So as you can see here, this particular business card has the contact information, the address and telephone number. And the address and telephone number are repeated, right? So I could have multiple addresses, I could have multiple phone numbers. In a traditional RDBMS, I would have to split them up into 3 tables. So the flip side of that is I'd have to do 3 reads to get the information that I want. Whereas in MongoDB, it's just 1 read in a document. So I've basically embedded the information for address and phones directly with the person's information, right? So that's the difference. Now, documents are, you'd notice that they're like key value pairs, like JSON, but we persist the data in MongoDB as BSON, binary JavaScript object notation. And the reason why we do that is because BSON gives us the ability to strongly type data. For example, in JSON, there is no decimal 128 precision denomination, right? So we don't have that. They just support for simple key value pairs. Here we could do, much more. We could do array of subdocuments. As you can see here, the orders has a bunch of repeating orders. That's embedding. So essentially, those are subdocuments. I could have arrays. So in this case, I have flat arrays, which gives me, the ability to store different values. I can have floating points. I can have geospatial information, very important for developing mobile applications. And in addition to that, I can also index and query at any level. right? And I don't need an ORM layer to translate that into an object because this is an instance of an object, right? And that's the important thing to know. So here's an example. You guys must have heard of the term polymorphism, where you can see different shaped information. So this is an example of polymorphism, where you have three types of policies. So you have a policy of auto, you have a policy of type life, and then policy of type home. In a traditional RDBMS, you would probably have to split into three tables if you're going to implement it in a physical way. Whereas in MongoDB, I can put them all in one collection because all it is just an instance of a type policy. It could be of type home, it could be of type auto, it could be of type life, right? And then we can use indexes to get the selectivity that I need during runtime for me to process the data downstream. So let's talk about embedding and linking. So in MongoDB, the way you model for efficiency is by understanding access patterns. So before I start any modeling activity, I'd have to first figure out how am I going to access the information. So typically the way we would approach embedding is any data that's accessed together is going to be stored together. It makes it very easy for me to build the performance because there are no joins. And with one read, I'm able to get all the information that I want, right? And it gives me a dramatic performance boost when I'm dealing with large volumes of data. And think about it, as and when your applications start to get complex and you're starting to process more data, this is going to give you the performance that you need. And the other thing to note in MongoDB is all the updates on any of those transactions that you do are going to be atomic within a document. So by default, atomicity is within a document. So this gives us the ability to perform any updates on the document by default, using the default atomicity. However, there are ways to essentially, if you want to do a two-phase commit, you can still do that. We have the ability to do that as well. The one thing to keep in note is the size of a document is 16 meg. And it may not sound all that big if you hear the word 16 meg, but if you were to compare and contrast it to a real-life example, it is like 8,000 pages full of characters. So that's a lot of information in one document, right? And keep in mind that because of the scalability that we offer out of the box, you can essentially have millions and millions and billions of documents. Like Carfax, for example, has 64 billion documents in MongoDB, right? All right. So linking is the equivalent of essentially doing keeping related data, so that you're able to join during runtime. So here, you usually consider linking when the documents are smaller in size and they're highly dynamic. So when you say dynamic, both entities are constantly changing, so it may not be prudent for you to put them together. So this is where you start to look at linking. Now keep in mind that there are also other considerations, like for example, if I'm not going to be accessing related information all the time, then it may be better for you to separate the entities, right? And then the one thing to remember is when you have linking, you are going to be doing joins via the application, or you're going to be using the aggregation framework operators like lookup and graph lookups. So that is something to keep in mind. And linking basically eliminates the need for you to do duplication. There are chances that you may be able to do both, but linking is predominantly for very strong entities on both sides of the equation. So let's see how we can model using the one-to-one relationship that we saw earlier in the shopping site example. So here's an example of where the customer placed an order, and it's just a singular order. So in the embedding relationship, what I do is I have the order essentially embedded with the customer, right? So this way, when I do my analysis of the customer, because in this case, the order is a weak entity and the customer is a strong entity, I'm always using the customer to drive the analysis, and the embedding makes perfect sense in this case, right? It's a sub-document. Order is going to be a sub-document, and a customer is going to be the main document. And if you look at linking, the way we would do linking is have the order number essentially be a part of the customer document. And this way, you can independently update the orders. If anything changes, for example, if the order moves to fulfillment, or if it gets returned, etc., it can be updated independent of the customer. So there is no need for you to update both the entities together. But the only thing is, in this example, you would have to use the application to pick up the order number from the document, customer document, and then go to the orders, and then pick up the order information from there, right? So let's look at how we would implement one-to-many relationships. So here, a customer has multiple orders. So here you'd see they've ordered the book, and they've also ordered the food processor, right? So the sub-document embedding is going to be like this. So here, the orders are multiple, right? So one customer has multiple orders. So you see the repeat of sub-documents with the customer's information. Again, the advantage of that is you're able to atomically update the information, and you're able to get all the orders by a customer directly by using the customer's ID with one read. Now, there may be chances that a customer will be ordering lots of items, so which means that, you know, if you have like thousands of items the customer's ordered, then it may be better to use a hybrid approach where maybe I just keep orders for up to 6 months and then use linking for the rest of the orders. This way, if the customer wants to, if the person wants to see what orders have been ordered for the last, let's say, 5 years, you can use linking to go to that collection and then pick up all the order information by the IDs. So one-to-many relationship with linking. This is assuming that orders are strong entities as well, and then constantly changing. I just carry the order numbers for both the entities in the customer collection. Now, keep in mind, because we support arrays and arrays of sub-documents, we can store as many values as you have orders. So this way, it keeps the document smaller, and it also helps you prevent data duplication. But again, the flip side of it is, you have to do as many reads as there are orders, right? So chances are you might want to invest in either an embedding with hybrid approach, if you want to carry data for over, let's say, 6 months or 1 year, or you might just want to do linking if the order and customer changes frequently. So again, the best practices are embed wherever you can, because the idea here is to take advantage of the atomicity that MongoDB offers by default, right? If always the determination of which to embed where is based on which entity is weak and which entity is strong. The weaker entity always goes to the stronger entity as a document, right? So that is the basic premise. You can index and you can query any field that you want. So it makes it easy for you to start to ascertain insights as and when you start to build the structures in MongoDB. And then the only thing to keep in mind is the document size is 16 meg. So it's a pretty big document, but chances are if you do exceed the 16 meg size, then you can definitely use linking to essentially split the entities together. All right, many-to-many relationships. So here's where a author can author multiple books, and the books can essentially be authored by multiple authors, right? So in this case, we have Randy Illig, and he has authored 2 books with Mahan Khalsa. So obviously there's a many-to-many relationship here. So let's see how we can model that in MongoDB. So we go up here. So embedding, again, here's where I can carry the book information of the author, assuming that I am doing my analysis by the author, or if I'm doing my analysis by the book, I can store the multiple author information directly as sub-documents in the books as well. Now, chances are, if you're going to do analysis by both sides, then it's okay to carry the duplicate information on both ends of the entities, right? So it gives me just the flexibility to do both. The advantage is I eliminate the join table that's in the intersection. So this gives me a lot more flexibility because I'm duplicating data for the sake of performance and also for the sake of analysis, right? So it makes it very easy to kind of put the documents together like that. You can also do linking if you want, but in this case, the linking, you'd have to essentially start to look at the array values. So as you can see here in the references, I have the A1, A1, A2 on the book side, and then I also have the B1, B2 on both the books on the author side. So you'd have to carry array of entries on both ends, right?
Here.
Okay.
Stay anytime you rotate.
Okay.
Yeah.
All right.
String between the hand and the mouth.
So the best practices for many-to-many here, again, we gotta understand the application pattern. If it's going to be pretty read intensive, then try to do embedding, because data duplication is okay as long as you're able to enhance the performance of reads, right? And then figure out which is the strong and which is the weak entity, because which changes the most. That gives you the answer of okay, do I put that as strong or weak, right? So that's going to be a key determinant. Also, if you have a lot of related entities, you can do linking and information. If it's going to be constantly dynamic, then use linking. And it's MongoDB's document model is so flexible that you can also adopt a hybrid approach as well, right? So I'll just walk you through some use cases very quick. So MetLife has been in existence for 145 years, 70 plus systems, all siloed. So they have their own variations of what a customer is, what policies are, etc. So they were losing a lot of money because nobody could give them a consistent view of the customer policies. So they started their journey to bring all the information together using a RDBMS. After 2 years and $25 million of expenses, it is a big failed project. So they chanced upon MongoDB. They were able to build an application called the Wall, where they were able to bring in all these different sources of information. And then they were able to move it into a prototype in 90 days, and then, in 2 weeks, and then they deployed to production in 90 days. So if you look at the Wall, this is how it looks. So anybody that's a MetLife policy holder, if they log in, they'll see the Wall, and it shows you the 360-degree view of the customer and policies on the left-hand side, and it basically brings together all the information from 70 systems, and then it took them all 3 months to essentially be in production. The reason is the flexible data model that we offer with MongoDB gives you the ability to be very agile and be very productive in a very quick fashion. So the next one is Cisco. So Cisco has an e-commerce platform that was built on a traditional database. The problem is there was a poor customer experience because the pages took very long to load. So they used MongoDB. So all they do is just fraction. They have to just change a fraction of the code that they used on the legacy system, and then they were able to see that they were able to load the pages much faster, and they're able to improve the customer experience much more. And this gives them the ability to essentially make it more revenue driven. So the commerce platform, it became a good experience for the customers, and they started to see a lot more improvements in revenue as well. So if I was to look at the e-commerce by numbers, so there's the 15 to 40 billion plus in order bookings, 4 to 6 million page hits per day, 140K unique users, and you look at the lines of code, it's 4 million, right? They had to just change a fraction of that to make it work on MongoDB. It kind of shows you the power of the document model. Right? So if you have any questions, I'll take them, otherwise I'll be available. Yeah.
I have 2-3 questions. One question is like we have a limit on a document, right? 16 megabytes is the limit. So how about the medias? If I want to have a customer side with videos.
Yep.
So do you recommend putting the video in file store or how I can store it?
So the question was, where would you put content like videos? Would you store them in MongoDB or would you put them in a file store? The answer to that is you can do either. So we have a facility called the GridFS. The GridFS gives you the ability to split the content like MP3s or other pictures, etc. Into 255K byte size and then spread them around as documents. Or the better option is to essentially put them in a store like S3 or or something like that, and then have a link to MongoDB as well. So there's two ways you can do it.
Same question is about the Cisco. You did the case study in Cisco. So how many sizes of cluster do you had for this Cisco data?
The size, I don't exactly have that information.
What was the question?
What is the size of the cluster?
First size for the database
Yeah.
servers?
We can find out. I'll take the card from you and I'll send you the answer. Yeah.
I have a question.
Yeah.
So if I decide to move our data to MongoDB, what about the old data? What is the migration tools or how the data is migrated?
So the question is, what are the steps to migrate from a traditional database to MongoDB, right? So keep in mind, when you look at moving from a traditional RDBMS to MongoDB, there's a lot of other aspects to be considered besides just the table. You may have things like PL SQL procedures, you may have triggers, you may have other components that may be active in your database. So from our perspective, we offer a professional services package that will help you basically put together a plan to move data from a RDBMS to MongoDB. But then we also have best practices, a white paper that we have published around best practices on how to approach a migration like this. And in addition to that, we also have a variety of tools, like for example, Informatica or Talent or Pentaho, that have capabilities to connect to MongoDB, extract data from MongoDB, or even extract data from RDBMS and put them in MongoDB. So there's multiple different options. So I'd highly recommend that you engage your professional services who can guide you through the process. Yes, sir.
So I had a couple questions. In one example, you had the orders collection with a series of the IDs in there, right? You're linking them together. And you said you'd have to do individual queries on each order. So I was wondering what the performance hit is in just using a $in and then including that collection in that query, so you do one query.
So that's the aggregation framework, right?
Right.
So you can do that. So again, what we are going for in that particular concept is in embedding, you're putting the data together, right? So I just do a simple read, I get all the information back. Whereas in the other side, where I have the linking, I have to use either an application to basically loop through and get all the related information, or I have to use the aggregation framework with lookup and graph lookup to basically get that information. So it all depends on what you want to do, right? In one case, everything is available for you in a simple read. In the other side, you have to use those operators to get the information that you want, right?
I guess my question is there other than the complication, the aggregate query is the bane of my existence, but performance-wise, is there a significant difference between doing a single aggregate to get the answers that you need, or doing 15,000, 20,000 queries?
So the simple answer to that is maybe. And the reason why I say that.
That is a simple answer.
Yeah, the reason for that is it's a function of the amount of data that you're dealing with. What kind of data are you dealing with? What kind of dynamism are you seeing on the entities? If the entities are going to be pretty static, or if one entity is kind of weak versus one which is strong, then obviously embedding would be a best way to approach the design. But if it's going to be constantly dynamic and it has been linked, then you have to figure out what is your trade-off with regard to the amount of data that you're processing. If the amount of data that you're processing is pretty massive as well, then try to look for the hybrid approach where I embed, maybe the recent, I don't know, in your case, let's assume that you have 3 years of data. So 6 months of data I embed, and the rest I use linking to go there.
Okay, so and along similar lines in terms of performance, I have a client who is in the IoT space, and they collect millions of micro logs, I guess is what I'd call them, where their devices are constantly pinging back, informing them of different conditions.
Right.
So for best performance in that, I mean, is there collection size limits in terms of getting good performance? Because initially there's not going to be a problem, right? But I'm thinking about 5 years down the line when they have billions of records. You know, what my recommendations to them should be.
So keep in mind, in addition to the document, just the documents, we also have the ability to shard the data as well.
Mhm.
Right? Sharding is going to be pretty key in kind of distributing the documents so that you don't scan through all the documents to get the answer that you want. And then there's also design techniques that you can use where, you know, there are a lot of articles in our website that kind of show you how to model for IoT. But you could basically store summarized information along with the granular information as well within the same documents, right? And then depending on the kind of analysis that you want to do, you can start to process the documents in a way, you know, that based on your use case. So there's a lot of things that we can talk about. I'm available offline, and I think Pat's signaling that he needs to get on the stage. But yeah, I'm available after the session, and if any of you have questions, we can chat. Thank you, guys.